Okay, the practical that you're going to do now is to make some copper sulfate crystals, bright blue copper sulfate crystals. Now, the reaction you're going to carry out is between carbon, no, it's not carbon at all, copper oxide and sulfuric acid. So I'm going to give you a practical sheet for this, but I just want to do a calculation first, because we're going to try and predict how much copper sulfate you're going to make. You'll make it and then leave the dishes on the windowsill and it'll crystallize over the weekend, and you'll be able to weigh it next week and see how much you've made. So you're going to weigh an empty dish first, and then you do the reaction, and then you put the solution in the dish, the water will evaporate and you're left with the crystals, and you can see how much you've made. And see if it matches the calculation that you do using moles. The reaction is copper oxide plus sulfuric acid, and it's a fairly simple outcome. It's copper sulfate plus water. All right, now that looks fairly simple. In fact, it's not quite that straightforward, because copper sulfate comes in two forms. You can have a dry white powder, which is actual copper sulfate, but if you make it the way you're going to do, as it crystallizes, the copper sulfate joins itself up to water molecules. So the bright blue copper sulfate that you see is actually copper sulfate and some water. The blue crystals that you get are not just the copper sulfate on its own, they are actually CuSO4, and then we put a dot because there are 5 water molecules attached to each one. So that water is going to come from what you've made. So when we're working out the whole formula mass and all that, you've got to take the water into account as well. Now, what you're going to use, it's not going to be hugely accurate, but it doesn't matter too much. You're going to use 20 centimetre cubed of the sulfuric acid. And the sulfuric acid has a concentration of 0.4 moles per decimetre cubed, which is a litre. So 0.4, we write it like that. If we had a whole litre of it, a decimetre cubed, there'd be 0.4 of a mole in it. You're only using 20 centimetre cubed. So we're going to have to work out how many moles of that we're actually using. All right. Now, so the number of moles of sulfuric acid equals, I'll put it underneath because it's going to be a relatively long calculation. How many centimetre cubed are there in a litre? Or a decimetre cubed? 1,000, yeah. We're using 20 of them. So we're using 20 1,000ths of a decimetre cubed. And if it was a whole decimetre cubed, it would have 0.4. But we're only using 20 1,000ths. So we're using 20 1,000ths of the 0.4. So this is how many moles of acid we're using. All right, if we used a whole litre, a whole decimetre cubed, we'd be using 0.4 moles. We're not. We're only using 20 1,000ths of that. Does that make sense so far? Because it's a way of saying that is the same as moles divided by decimetre cubed, or moles slash decimetre cubed, which is the same thing. If the decimetre cubed is underneath, which it is there, you use a minus index. Yeah? All right, so how many moles of sulfuric acid do we use then? Not very many. What you should find is that's 8 over 1,000. So it should be, if you've done it in your calculator, it should come out at that.
How do you put that out?
20 times 0.4. Yeah. 20 times 0.4 is 8. Divide the whole lot by 1,000 and you get 0.008. Okay. How many, hang on, I need to check, I've balanced that up there, don't I? Does that balance? Actually, it does, doesn't it? So, how many moles of copper sulfate are we going to get? How many moles of sulfuric acid did we use? 0.008, we've just worked out. So, how many moles of copper oxide will react with that? Yeah. And how many moles of copper sulfate will we get? Yes. Because the ratio is 1 to 1 to 1 to 1, if we know how much acid we've used, we know how much of everything else is involved. And what you'll have is the acid, which you'll warm up, and you'll add copper oxide until no more reacts, so there'll be a bit left over. You can then filter that out, but you'll know you've used all the acid up, and as much copper oxide as would react. Yeah? So you'll know that you should have 0.008 moles of copper sulfate. So moles of CuSO4 and the water, because that is produced, run out of space, 0.008. But what will it weigh? I'll say predicted, because you can actually weigh it next week. Okay. Well, 1 mole of CuSO4.5H2O has, yeah, a mass that we've got to work out. Right, copper, 63.5, sulfur's 32, 4 oxygens is 64, water's 18, 5 lots of 18 is 90. I think I've got those right. 4, 5, 6, 15. I've done something wrong. I haven't lined them up quite right, have I?
Can you tell us what they are, just so I can put the CU and the SO next to them?
Do what, sorry?
The individual masses.
The numbers.
Yeah, the individual
Copper, sulfur, oxygen, water.
copper, sulfur, oxygen, water.
Yeah? It's,
249.5.
thank you very much. 249.5. I just got those out of my head, so there's no guarantees.
Oh, right.
Right. I do know most of the useful ones, but 249.5. So what we're producing, though, is 0.008 of that. That would be a whole mole of it, would be 249.5 grams. Quite a lot. No, you multiply it, 249.5, but we only have 0.008, that fraction of it. So that comes out at roughly 1, 2, 3, 1, 2, 3, 8, so about 2 grams. 1.996 grams. That's what we're expecting to make. All right, so what you're going to do is measure out 20 centimetre cubed of acid, bring it up to just about boiling. You don't want to boil acid too much, but it's only very dilute, so it's not really going to be a problem. You don't want it splashing out. You're going to add copper oxide gently. It will react and you'll get a blue colour forming, but you'll get the black copper oxide powder left in it as well. So you have to let it settle a bit and see if you can, get to the point where you've just got a bit left over. Then you pour it through a filter funnel with a filter paper in it. Now the problem with that is, of course, you'll leave some behind, won't you? There'll be some left in the beaker, some left in the filter paper, but you can wash that out with water and tip it through, because you're not, the concentration doesn't matter. You can add extra water and it's not going to cause any problems. So you can wash that through until you get all the blue stuff into an evaporating dish. You did this right at the beginning of the chemistry with the separating salt and sand. So you put your blue solution in there, heat it up gently so that it comes to a boil and you're losing some of the water, because you need to be careful you don't get that too full. And then when it's perhaps about half full, you can take a bit of paper, put your name on it, sit it on the windowsill, and then next week you can see what you've got. Weigh the dish before you start, though, because next week you'll weigh it with its blue crystals in, and we'll see if it's gone up by about 2 grams. All right, so I'll give you the instruction sheets for that, and you can have